Walk into a modern corporate meeting room and you usually see a sleek, minimalist table with a few polished microphones. But to understand how these spaces actually operate, you have to look inside the AV closet. That is where you find the legacy hardware, massive 7-foot-tall racks packed tightly with proprietary black box switchers and controllers. Getting these disparate boxes to communicate requires hiring specialized third-party programmers to write highly niche code. This creates a reactive break-fix environment. When a single component fails right as the CEO walks in for a pitch, the entire room drops offline, and you are stuck waiting for a technician to diagnose the rack. The solution to that fragility is condensing that entire mountain of physical gear into a software stack, running entirely on a standard small form factor Windows PC. This chart shows the immediate financial impact of that physical pivot. By replacing highly specialized proprietary boxes with standard off-the-shelf PCs, the initial capital expenditure drops by 30 to 40%. Shrinking the physical footprint eliminates the specific financial and operational bottlenecks inherent to legacy infrastructure. Dropping a dedicated PC into the conference room gives the physical space its own localized brain. In the old model, a dead microphone meant the room stayed broken until an employee noticed, filed a manual support ticket, and IT dispatched a team. A software-defined room removes the human from that troubleshooting loop. It can monitor its own live audio and video bit rates 24 hours a day, continuously checking for dropped packets. If an audio profile drops out, the local AI detects the anomaly and resets the connection automatically before users even notice. That monitoring continues after everyone goes home. The system runs automated health checks every night, testing every connection while the campus is empty. Autonomous monitoring turns IT from a reactive crisis team into administrators of a quiet, invisible utility. Bring this kind of intelligence into a high-stakes corporate boardroom, and you run into a serious privacy concern. Most smart automation requires piping sensitive audio and video data out to external cloud networks. Because the system uses a private AI engine running directly on the local PC, that automation data stays entirely within your on-premise network. The packets bounce right off the perimeter, ensuring nothing leaves the room. This local software layer also solves the 5-year hardware trap. Historically, keeping a room current meant ripping out the walls and replacing the physical gear every few years. Instead of buying a new box to get a new feature, the system is forklift upgradable. You push a software download over the network, entirely updating the room's capabilities without ever touching a wire. The meeting space now functions as a secure digital platform, capable of continuous capability updates. Once you step back from a single boardroom and look at an entire university campus or corporate headquarters, the math scales aggressively. Because these spaces are entirely software-defined, IT can use network cloning to instantly push a master configuration to 200 rooms simultaneously from one central server. But creating a massive grid of hundreds of identical, high-powered PCs reveals a glaring inefficiency in modern real estate. These machines sit totally dormant in dark rooms for up to 16 hours every day. The unified middleware layer can coordinate background tasks across the network, effectively pooling idle processing power. When the building clears out, the management server assigns data tasks to the inactive GPUs, acting as a single distributed unit to process massive campus-wide AI tasks overnight. And the people managing this system evolve right alongside it. Instead of spending their careers learning highly specialized, dying coding languages, IT staff build durable, cross-platform skills in PC networking and AI management. Removing legacy hardware simplifies the individual room, while using the same network to recapture idle processing power provides a viable resource for campus-wide computation.